What's going on, everybody? This is going to be the review of the 1.2 across the spectrum, and then we'll be going over 1.3, 1.4 in McGraw-Hill. So in the public chat, go ahead and a person can just put in radio waves. Describe the wave frequency, the wavelength, or the energy along with a characteristic, like how it's used, what it's used for. So the first one is just radio waves. And then for those of you that did turn it in, I believe I already graded your assignment. Excellent, excellent. Excellent. And for the people that are watching this video, we're going to kind of expedite this pretty quick. Go through it pretty fast. So for the people in the public chat, if you just want to do a large answer with just going across all three of these instead of just the purple category and the pink category, just go ahead and go across the whole thing. Yeah, radio waves are huge. Anywhere 30 centimeters is about this to a kilometer, which is a little bit over a mile. And it's used for communication. You know, radio frequencies is what you get everywhere. Lowest frequency. Microwaves. Go ahead, microwaves. And if you already answered, you can answer again. If you did not answer, you can definitely answer. So microwaves. What are the wavelengths of those microwaves, and what are they used for? I think that one's fairly obvious. Right, and as a life pro tip, don't forget on the microwave you can use different heating levels, and also if you take your plate of food, if you make it like a donut, you put a little space in the middle, it'll actually cook the food a little bit more evenly. Let's go into infrared waves. Oh no. I had a remote in here to show you a demonstration, but it was probably cleaned up. Like, it's used to send short signals, and it is shorter than 1 millimeter. So again, if you look at a regular school ruler, a millimeter is like those really tiny little lines, so they're pretty small waves. If you have a traditional remote control that has like a little dot on the end of it, you can actually hold it up to a camera, and as you're pressing the button, you should see it in a camera. You should see it blink like a purple color. And if you go to a hotel, you can take your camera from like your phone and look for places that are dark, like maybe behind a digital clock. And if you hold this up, it's just your camera mode, just your plain camera. You don't have to take the photo. You don't have to take a video, just your camera, and you scan the room. In your camera, if you see any sort of purple light, that means there's probably some sort of infrared connected to like a video recording device. It's just kind of like a little like safety tip. Anytime you go to different places, use your phone and scan the room, and if you see a small purple light sticking out, that's just kind of on or blinking somewhere, there's probably a camera recording. For all you spies. I mean, it's just a way to protect yourself, or like it's also like security. It's also security. What about light waves? What are the description of light waves and maybe examples? What are the description of light waves? So again, what are the descriptions of light waves? Okay, so for the light waves, we know that light waves are, um, they have like a mix of wave frequencies. And for light waves, you could actually say Roy G. Biv. And Roy G. Bivs are all of the colors in the visible spectrum: red, orange, yellow, green, blue, indigo, violet. Can somebody post the wavelength of visible light? Kind of like that, those nanometers. And then for ultraviolet, we had somebody submit a very nice answer. Ultraviolet rays can be used for disinfecting things. I know there's a trend right now where they have different type of cases, and they have, you can put things in the case like your phone, keys, and so forth. And they have ultraviolet rays that will kind of kill and disinfect different items. Sometimes you'll see these in restaurants. They have air filters that have UV lights inside of them. The problem with the air filters is the air particles have to be in there for at least like half a second. In the way that those things circulate air, there are studies that show that the air travels too quickly through that and doesn't do an effective job of killing all of the airborne bacteria, pathogens, whatever. And also, if the light gets even just a little bit dusty, it becomes very ineffective. For X-rays, we have a short wavelength, but a high frequency. And it can be used to travel through soft tissue, so it's just basically used for looking at the inside of you. The gamma rays are the shortest, and they're pretty intense, and they do kill cells. They're used in cancer treatment. And then can somebody still put the frequency of visible light? Maybe just do a quick little search for that. And that'll basically do it for that table. I want to say it's 400 to 700 nanometers. All right. Next section. We're going to go ahead and move on to the 1.3. And in this section, this is in the Wednesday folder, Wednesday the 20th. I went ahead and just popped them into 3 sections because the reading. Thank you. The reading's in 3 sections, and these are just surface level questions. They're not very in depth at all. So you're basically just scanning and looking for the answers. So in the first 2 questions, unit of measurement for wavelength, and what are the wavelengths for lights. So I'll leave that right there. Here's the next section for energy. The 2 questions we are answering for energy are: what gives high energy in a mechanical wave? What gives high energy in a mechanical wave like water? And how can energy be increased in an electromagnetic wave? In the brightness section, we're looking at the question, how is intensity measured? How is intensity measured?